Welcome to my world, where thermal imaging meets artificial intelligence and dredging operations become smarter.
What's up, tech enthusiasts? I'm Joel, your friendly neighborhood structural engineer who gets way too excited about anything that combines AI with real-world engineering. Thermal camera at coffee mug, this is 147 degrees Fahrenheit. This is my brain when I think about AI turbidity monitoring. And this is about to become the smartest environmental monitoring you've ever seen.
Let's start with the reality we're facing. The UN projects that by 2050, climate change will reduce urban water availability by at least 10%. Meanwhile, water scarcity and pollution have become global crises that traditional management systems simply can't handle. But here's where it gets interesting. In 2025, we're seeing AI and smart technology transform water management from reactive to predictive. Companies like Xylem, Idrica, and emerging startups are deploying AI systems that can analyze millions of data points in real time. Today, I'm breaking down 5 game-changing technologies that are revolutionizing how we ensure clean water for everyone. First up, turbidity monitoring. Turbidity measures water clarity, how much sediment and particles are suspended in water. Traditional systems could only react after contamination occurred. Now, AI-powered turbidity sensors like those being deployed by New York City can predict contamination upstream before it reaches treatment facilities. These systems use machine learning algorithms trained on historical data to forecast when storms will increase sediment levels. Here's the game changer. Instead of shutting down operations after contamination hits, utilities can now prepare days in advance. That means continuous clean water supply even during extreme weather events. The University of Vermont just developed an AI tool that combines national water model data with real-time sensors to predict water quality across the entire United States. This isn't just monitoring, it's forecasting the future of water safety. Smart sensor networks are the nervous system of modern water management. We're talking about sensors that monitor pH, dissolved oxygen, temperature, conductivity, and dozens of other parameters, all in real time. Systems like Grenviro's Diac X deploy IoT sensors that continuously monitor water quality without human intervention. These sensors collect high-frequency data and use AI algorithms to detect trends, identify patterns, and predict problems before they escalate. But here's what makes this revolutionary. These systems don't just collect data, they learn from it. Machine learning algorithms analyze patterns across thousands of water systems to predict when and where problems will occur. Advanced systems now use spectroscopic analysis with AI to distinguish between clean, contaminated, and UV disinfected water samples with remarkable precision. We're seeing random forest, support vector machines, and neural networks process spectral data in real time. The result? Water quality issues that used to take days to detect are now caught in minutes. Digital twins are virtual replicas of physical water systems that update in real time. Think of it as having a living, breathing computer model of your entire water infrastructure. Korea's K-Twin SJ platform manages the entire Sumjin Dam and river system. 4,913 square kilometers of watershed, 173 kilometers of river, and 91 water infrastructures. It uses real-time data and simulation models to support flood response and water resource management. These digital twins integrate IoT sensors, cloud computing, and AI to create dynamic simulations. They can predict equipment failures, optimize treatment processes, and even simulate the effects of extreme weather events. Valencia, Spain uses digital twins for proactive water management, enabling the city to respond to droughts, flooding, and water quality issues before they become critical. The system optimizes resource allocation and supports informed decision-making. Companies like Alibaba Cloud and Huawei are using digital twins to optimize drainage systems and predict flooding risks in major cities. This isn't just monitoring, it's prevention. Water utilities lose billions of gallons annually to leaks and equipment failures. AI is changing that equation with predictive maintenance that can forecast problems months in advance. AI systems analyze data from pressure sensors, flow meters, and acoustic monitoring devices to detect the early signs of pipe deterioration, valve failures, and system anomalies. Machine learning algorithms process this data to predict exactly when and where failures will occur. But it goes beyond leak detection. AI optimization systems are reducing energy consumption in pumping stations and treatment plants by 25% by using predictive models that tailor operations to actual demand. A major UK water utility is using AI-driven predictive maintenance to reduce leak events and optimize operations. The technology transitions utilities from reactive maintenance to AI-driven predictions, preventing catastrophic failures before they happen. The financial impact is massive. Preventing one major pipeline failure can save millions in repairs and service disruptions. AI is revolutionizing how we actually treat water. Advanced systems now use machine learning to optimize chemical dosing, control treatment processes, and ensure consistent water quality. In 2025, AI systems are fine-tuning processes like reagent dosing and treatment line control in real time. Digital twins simulate complex scenarios to anticipate problems before they occur, while AI algorithms adjust operations based on incoming water quality and demand patterns. For wastewater treatment, AI monitors and adjusts biological processes to ensure microbial communities effectively break down pollutants. The systems predict incoming wastewater loads and adjust treatment processes accordingly. Companies like Veolia Water Technologies use AI to optimize wastewater treatment plants worldwide, reducing both energy consumption and operational costs. These systems support more sustainable practices while achieving higher environmental protection standards. The result is cleaner water with less energy, fewer chemicals, and lower costs. Let's look at real results. New York City's AI-powered turbidity prediction system prevents supply disruptions that used to cost millions in lost revenue and emergency responses. Singapore's smart water management platform reduced non-revenue water losses by 15% in the first year. Amsterdam's AI-driven flood prediction system has prevented over 50 million euros in flood damage since implementation. These aren't pilot projects. They're proven systems being deployed worldwide. From China's digital twin water networks to Brazil's IoT-enabled precision irrigation, AI is solving water challenges at scale. Now, implementing these technologies isn't without challenges. Data quality remains a major hurdle. AI systems are only as good as the data they receive. Integration complexity is another barrier. Water utilities often have legacy systems that need to communicate with modern AI platforms. Plus, cybersecurity becomes critical when your entire water infrastructure is connected to the internet. But the biggest challenge? Finding skilled personnel who understand both water management and AI technology. The industry is investing heavily in training and partnerships to bridge this skills gap. Looking ahead, we're moving toward fully autonomous water systems. Imagine treatment plants that adjust their operations automatically based on weather forecasts, distribution networks that reroute water around problems before they occur, and quality monitoring that catches contamination at the molecular level. Beyond 2025, expect integration with generative AI for advanced scenario planning and blockchain for secure data sharing among stakeholders. We're building water infrastructure that doesn't just respond to problems, it prevents them. The companies and cities implementing these technologies now are building the foundation for water security in an uncertain climate future. For water utilities and engineers looking to get started, begin with specific pain points. If you're dealing with frequent equipment failures, start with predictive maintenance AI. If water quality is your biggest challenge, focus on smart sensor networks. The ROI is compelling. Utilities typically see 15 to 30% energy savings, 20 to 40% reduction in maintenance costs, and significant improvements in water quality compliance. Most systems pay for themselves within 2-3 years. Partner with technology providers who understand water infrastructure and invest in training your team. This technology is transformative, but only if you have people who know how to use it effectively. AI and smart technology aren't just improving water management, they're making the impossible possible. We're talking about systems that can predict the future, prevent problems before they happen, and ensure clean water even in the face of climate change. From turbidity sensors that forecast contamination to digital twins that simulate entire watersheds, these technologies represent the future of water security. The question isn't whether this technology will transform water management, it's whether you'll be leading that transformation. What's your experience with smart water technology? Are you working on any AI implementations in water management? Drop a comment below and let me know what innovations you're most excited about.
And hey, if you got value from this first video and it resonates with you, I'd love it if you would let me know by subscribing or by clicking the thumbs up button. In every video, we're diving into the tech reshaping, construction, and beyond. So for now, work smart, stay safe, and I'll catch you on the next flight.
Hey everyone, Joel here. Now, I've seen a lot of infrastructure in my career, but what's happening in water management right now, it's absolutely mind-blowing. We're talking AI that predicts pipe failures 3 months before they happen. Smart sensors that catch contamination in real time. And get this, Microsoft just built data centers that use 0 water for cooling. If you're a contractor who likes saving serious money, or someone eyeing a $40 billion industry, buckle up. Because we're diving into a revolution that's literally saving cities millions. Barcelona, beautiful city, right? Tapas, beaches, Gaudi, but also, they just saved 58 million annually with smart water tech. 58 million. And one leak detection company, their client got a 3,400% ROI just by preventing 300,000 in damages. As an engineer, I live for numbers like that, and these are bonkers. But here's the kicker. This isn't some future fantasy. Yorkshire Water cut visible leaks by 57%. Mexico City's saving 800 million liters a year with Amazon's help. The tech has hit that sweet spot where it's not just working, it's basically printing money faster than my mom prints coupons.